In this lesson, we're going to learn about the relationship between pressure and volume in gases, which is called Boyle's Law. So according to Boyle, pressure and volume of a gas when we have a certain mass, so no change in mass and no change in temperature, the pressure and volume are proportional at that point. So we can see from this diagram that if I have a certain pressure, so here my pressure is being measured in millimeters of mercury. So when I have a certain pressure, this is my volume. When I increase the pressure, my volume decreases. And when I increase it even more, the volume decreases even more. So look at a quick simulation here. So we're going to use different masses on top of this container to push that lid down to exert more pressure on there. So as I change the mass and add more pressure onto that container, I can see that the volume is decreasing. So the particles have less and less space as I change that. And you can see up here that the temperature is being kept constant here. So an increase in pressure decreases my volume, a decrease in pressure increases my volume. And we can see that here with this graph as well, that as I increase my pressure, my volume is decreasing. So we can see that here as well, same type of graph. So as my pressure increases, the volume is decreasing. So this first graph shows a graph between the pressure and volume, and we have an inverse function here. So as one is increasing, the other is decreasing. And this graph over here shows volume as its reciprocal. So for each volume value, we're dividing one by the actual volume. And when we do that, we get a straight line relationship. And so because this itself is the inverse of volume, that means that we have an inverse relationship. So as one increases, the other will decrease. So that is the results that Boyle found, is that when the volume of a gas is increased and the temperature remains the same, the pressure is going to decrease. Or if the volume decreases and the temperature stays the same, then the pressure will increase. So mathematically, the relationship there is the initial volume times the initial pressure is equal to the final volume times the final pressure. So whatever I start with here for volume and pressure, if this number increases, then this number needs to decrease for the overall amount to equal what it was before. So for example, if the pressure of helium gas in a balloon has a volume of 4 liters at 210 kilopascals, what would the pressure be at 2.5 liters? So if I decrease the volume, what would happen to the pressure? So I've got my relationship there. Initial pressure times initial volume equals final pressure times final volume. So I have to start with 210 kilopascals for pressure, 4 liters for volume. And we're going to solve for the final pressure, and the final volume is 2.5 liters. So this operation here is a multiplication. So to undo that, I'm going to divide by 2.5, which would cancel it on this side and put it on that side. So once I solve for that, the pressure is 340 kilopascals. So for Boyle's law, we are always using this relationship. One of them is going to be an unknown. Whichever one we are solving for, we will move what is beside it over to the other side and solve. And we just need to make sure that whatever we have information for, so in this case, we have 2 volumes, we need to make sure that those are in the same units. And then whatever we are solving for, the units will be in the same units as the other measurement for that variable. So in this case, pressure is going to be in kilopascals. So if I had liters and milliliters, I would need to convert one of them. It doesn't matter which one I convert. If I was given 2 pressure amounts and they weren't both in the same units, I would need to convert one of those.